Hello, welcome back to our next part here in Chapter 4. Here we have our illustrative example. Hopefully you took time and tried to create a box plot, and let's see how well you did. So we're going to jump right into it. Here we have a 5-point summary of 5, 21, 27.5, and 42, 52. So remember, our 5-point summary is going to be our Q0, our Q1, Q2, Q3, and Q4. And what you want to do from your box plot is you're going to box your Q1 to Q3 with your line through your median, and then you're going to extend your whiskers out to the maximum and minimum values. However, you have to determine if those maximum and minimum values are outliers in your set. They might be outliers, they might not be. In order to do that, you have to calculate the IQR. Here you have IQR equals 42 minus 21, which is going to equal 21. And then from that, you're going to determine your fences. You're going to have an upper and lower fence. So your upper fence equation is your Q3 plus 1.5 times IQR, and your lower fence is going to be Q1 minus 1.5 times IQR. So what you have to do is put the values that you have already done. So your Q3, which is going to be your 42, plus 1.5 times the IQR of 21 is going to give you a value of 73.5. So this is your upper fence limit. So now you're going to look and see, is there any value greater than 73.5? Well, our max value is 52, so no value is greater than 73.5. So there's no outliers as far as our upper fence goes. But now we have to look at our lower fence. So our lower fence is Q1 minus 1.5 times the IQR, so 21 minus 1.5 times 21, which equals negative 10.5. I believe we're dealing with age here, so we're not going to have a negative 10.5 for age. However, even if with these numbers represent something else, we do not have a value that is less than negative 10.5. So if we had a value that was less than, we would look at something like a negative 11 or negative 20. That would be less than negative 10.5, right? And that would be considered an outlier on our lower fence. Since we don't, our whiskers are actually just going to extend to our Q0 and Q4 respectively, and that's going to be our box plot. So when some of the values are above the upper fence or below the lower fence, we draw our whiskers as done. So as you can see here, we have our upper inside values, so that's our maximum value here. These are our whiskers and lower. And then we have our box, which is the Q3 to Q1, that is our box with a line through the median there. And that is a box plot. Hopefully yours looks something very similar to that. Next, we're going to do box plot 2. So if you like, this is a great time. Pause the video, write down the data that we have here, and see if you can draw a box plot 2. Okay, if you pause the video and did it, let's go over it. If not, we're going to jump right into it. So here is our data. And we have our 5-point summary, which is going to be 3 as our Q0, 22 as our Q1, 25.5 is Q2, 29 is our Q3, and 51 is our Q4. So ideally, we're going to box between Q1 to Q3 with our line being in the middle where our median is, and then hopefully whiskers to our upper and lower values. However, we don't know if our upper and lower values are outliers or not. So we need to determine the IQR. I do want to point out there is a little typo here. This should be 29. That'll be fixed in the PowerPoint that is going to be up on Canvas. But this value is still the same. So we're going to find out our IQR. So we're going to take our Q3 minus our Q1, 29 minus 22, which equals 7. And then we're going to figure out our fences, our fence for upper and lower limits. So we have our Q1 plus 1.5 times the IQR, which should say 29 plus 1.5 times 7, which will give you 39.5, and 22 minus 1.5 times 7 equals 11.6. So we're going to look, and we have 39.5 as our upper fence. So we're going to look, and we have a value of 51. Well, 51 is greater than 39.5, so that value is outside our fence. So 51 is actually going to be an outlier. And then when we look, we have 11.6. Well, we have a value of 3, and the value of 3 is also lower than 11.6. So this guy right here is also going to be an outlier. we'll see that we have one above the top fence, which is 51, and one below our bottom fence, which is 3. So our upper now inside value is actually going to be 31, and the lower inside value is going to be 21. We go to the next data point in the set, right? It's the next one in the set, and that's where we draw our whiskers. So now when we do our box plot, we're going to plot where the outliers are. Either sometimes it's a dot like here, or it's an X, or a box, sometimes it's a star. We're just notating that this is an outside value, that this is an outlier. And you'll notice the same thing down here for our lower value. And then our box is still the same, where we have our upper and lower hinges still on our Q1 and Q3, and our median still drawn the same in there. And then we just put our actual whiskers to the next closest inside value. So that'd be, like I said, 31 and 21 is where they draw those. So when you read this box plot, you realize that the value of 3 and 51 are outliers. The next closest value in the data set is 31 and 21, and then we still are reporting in our box where the Q1, Q2, and Q3 are. So here we have another box plot 3, which 7 metabolic rates. Go ahead, pause the video, and go through this one and see if you can draw this box plot as well. We're going to get right into doing this box plot now. So here we have our 5-point summary, which once again is going to include our Q0, Q1, Q2, Q3, and our Q4. We have our values here, so we could literally box this, but we need to determine if there are any outliers within this data set. So we need to find the IQR. So our IQR is going to equal our Q3 minus our Q1. And we're going to get a value of an IQR equaling 279.5. We're now going to determine whether or not we have any values on the upper or lower fence. So we find our upper fence, which is going to be our Q3 plus 1.5 times IQR. Plug these values in, and you're going to get a value of 2,149.25. We look, and our maximum value is 1867, so we have no values that are greater than our fence limit will allow us to, so there's no outliers above our fence. Now we have to do our lower fence, which is Q1 minus 1.5 times the IQR. Put in our values here, and we'll get a value of 1,030.25. Once again, we're going to look, and there is no value less than 1,030.25. Our lowest value is 1,362, so there are no outliers in this data set. So we're going to put our whiskers at our normal areas of our minimum and maximum here, and your box plot should look something like this. Once again, where you're going to box your Q1 to Q3, and you put a line where your Q2 is. Report our upper and lower whiskers, which is going to be your Q4 and your Q0. And since we have no outliers, that is notated because there is no dots or stars somewhere else, so there is no outliers in this data set. So we have box plot interpretations. Once again, box plot, you want to look at the position of the mean and the position of the box. This can tell us location, right? If we know in the box plot the line in the middle of the box plot is going to be our median. We can tell the spread from the hinges, and we can determine our IQR. We can determine the range, and the whisker to whisker is the spread, right? And then we can tell shape. We can tell the symmetry or the direction of the skew. Long whiskers would be the tails. Could indicate leptokurtosis. Remember, leptokurtosis is where we have long tails in the data set. Remember the example of the 2 kangaroos that can leap, they'll be leptokurtic. And so if you have long whiskers, there'd be long data sets in the tails, which shows you how the distribution is spread. You can also have side-by-side box plots. These box plots are especially useful when you're comparing groups. If you want to look here, you can look at group A, right? Everything's really squished. It's hard to tell, but you do know there's some outliers here around 20, and we know that there's a low value of 10, and everything else is kind of squished right here in between. So whereas B, we can really tell that this will be your Q0, Q1, Q2, Q3, and Q4. No outliers are present. We can tell a lot about, especially B's box plot in general. For A, it's going to be a little hard to decipher where things start and end. So something like this, where if the scale was actually a little bit bigger, where we actually could zoom in right here so we could get a little bit more information, that would be really great. But we don't, and so we're just comparing these two groups, and you can see that there is a greater spread, greater variability within B. A, not so much, and even the data set that they collected with A, because the data points are so collected right here, that there are outliers within the data set within itself. So just things that we can look at when you have side-by-side box plots and comparing them. So here we're now going to get into spread when we're talking about standard deviation. This is the foundation that we base a lot of statistical analysis on. And I'm going to start off talking a little bit about standard deviation and then cut off because I want you to practice standard deviation, and I want to make sure I have enough time to get through an example problem in here. But standard deviation is the most common descriptive measure of spread. It's based on deviations around the mean. This figure demonstrates the deviations of two of its values. So here we have deviations. So a deviation is how far away a certain point is from the mean. So they have an example here where they're using the data point 32 and the data point of 40, and the mean of this sample is 36. And if you were to take the 32 minus 36, you'll get -4, and 40 minus 36 is 4, which is telling you how far away those data points are from the mean itself, right? And this is just the deviation. The deviation is just how far away data points are from the mean. Now, if we know the deviation is x sub I minus x bar, that tells us how far away a certain point is from the mean. That's a deviation. Before I go into that one, if you were to take all the deviations and just add them all up together, your deviation is going to be 0, right? Because the deviation is a certain distance from the mean. Well, the mean is calculated by all the data points together and where the center of the spread is. So all the points, when you just add up their deviations, it will sum to 0, because some are going to be less than the mean, some are going to be greater than the mean, and the total is going to sum to 0. So that doesn't really tell us a whole lot except how far a certain data point is. In order to find out a little bit more or less the spread around the mean, we have what's called the variance and standard deviation. And these are how we start to calculate that. So when we have the deviation is going to get to 0. In order to get a value that's actually going to be worth it, we're going to need to square these values, because anytime you square a value, we're going to get a bigger value, and we can determine a better spread from it, right? So if we had a -4 deviation, when we square it, it's 16, right? Because a negative times a negative is a positive, and then we can sum those squares, right? So this is called the sum of squares of deviations. So we're taking the deviations, and then we're squaring them, and then summing them in order to get a more accurate representation of how far certain data points are from each other. And this is called the sum of squares. So you take the deviation, you square them, and then you add them together, and that gives you your sum, which is also the notation here, right? So you have x sub I minus x bar, which is our deviation. We're going to square them, and then we're going to add up all the squares, and that's the sum of the squares. Once you take your SS, which is the sum of squares, you divide by n minus 1, which is called the degrees of freedom. We'll cover that a little bit more as we get closer, but right now we're going to take n minus 1. That gives you your degrees of freedom. And when you do this, you'll then end up with what's called S squared, which is your sample variance, right? Since our units are squared, this value is going to be squared, so S squared. This tells us our variance of the sample. In order to go from our variance to standard deviation, we take the square root of S squared, which is shown here. The square root of S squared will then give you S, which is our standard deviation. And then this is the notation for standard deviation, which we just covered. You can find that on page 93. As you can see, that's the sum of squares there. So here on page 92, they go over the sum of squares and go through it. I'm going to cover this more in the next video and then go over a practice problem as well. All right, we'll see you all in the next video.